All right. Good afternoon, everyone, and welcome to HIMSS 2017 and the Philips booth. We are getting ready to begin our next exciting forum presentation here, and we have a very good one for you. We're going to be talking today about extending the cloud, and to do that, our friend Colin is here from AWS, and he'll talk about how Philips and Amazon are partnering to make that a reality. So we tend to fill up and have standing room only. If you're passing by, though, please come in and grab a spot. You might as well be comfortable while we sit for this. We've done things a little differently in our forum. Rather than just doing any kind of like a consistent marketing pitch or the same thing over and over, we decided we'd get right to the people that you're here to hear from. So we have a lot of our senior leadership from Philips, a lot of our key partners and customers, and some well-known names in the connected care industry as well. So if you want to see a full lineup of our speakers, I encourage you to grab one of these schedules from over there on the desk before you go. And it will tell you all the different offerings we have and the speakers that are coming up. Some of you might be familiar with ePatient Dave. He's got a blog that a lot of you might know about. He'll be here this afternoon, so you can check out the lineup. But again, welcome to the Philips Connected Health Forum. My name is Paul Trainer, and I am your host this week. So as I said, between now and Wednesday, we have exciting sessions with outstanding speakers on topics ranging from population health and care coordination to advanced analytics and clinical informatics. All are happening right here at the forum, starting at the top of every hour. So grab that schedule, and you can see the topics and times before we go. Now, this session is called Extending the Cloud. Now, most of you know leveraging the cloud in healthcare poses new challenges and requires critical elements like speed, connectivity, and encryption. Well, that's why we're very pleased that Colin Leasure, Director and General Manager of Amazon Glacier and AWS Snowball, is here with us today, along with Rich Rodolfo, who is our Senior Director of Operations and Infrastructure and R&D for Philips HealthSuite Digital Platform. I think I got all that right. We're talking about, they'll be talking about how Philips and Amazon are working together to extend cloud functionality to care facilities. And so, if you would right now, please help me welcome them to the stage. Gentlemen. Thanks, guys. Thank you.
Thank you. So welcome, everybody. A quick overview for those of you who haven't been through one of these presentations before. What is HealthSuite? HealthSuite is Philips' common platform for both ingestion of new data, whether it be from IoT or from modalities, data storage and analytics on that data, and real-time delivery of it across facilities. We'll talk a little bit more about some of those capabilities later in the presentation. As many of you are aware, the challenges bringing the cloud into the healthcare space is a little tougher than some of the other industries, and we'll talk a bit about that, as well as how Snowball Edge from Amazon fits into our product solution and how it helps us extend the cloud down into your premise solution. Some of the challenges, which will be familiar to most of you around healthcare and IT, focuses on the requirements of healthcare. So real-time patient care dependent upon IT becomes a little more challenging when the connection to that data could be interrupted at any time. And while we want to help move healthcare further into the cloud faster, we do have to address the very real risks and challenges with that model. We also have some performance considerations. In trying to move your data distally from where the patient is located, you introduce new things that we haven't had to deal with before. That may be latency, that may be bandwidth constraints, that may be other things that get in the way. Connectivity, as we'll talk about a little bit more, is sometimes a reliability challenge, and just simple availability for the amount of bandwidth that we need to support some of these applications is problematic. User perception and trust for us is a unique challenge in healthcare. Moving too fast, changing technologies quickly works against everything that we've grown to expect, which is mature technologies that we're very familiar and very comfortable with. So we wanted to address some of those concerns about what happens when I send my data somewhere else, where I can't touch it, where I can't maintain it. And then lastly, it's the scale. And as we all know, that the amount of data coming out of healthcare facilities is growing at many orders of magnitude every year, and we wanted to make sure that we could deal with that growth, both in the cloud and locally. One of the biggest factors, one of the continuing problems that we have is broadband connectivity. And while we like to think, even in the U.S. market, that there's pretty wide delivery of the internet, there are very significant challenges in some parts of North America and indeed the rest of the world. 10% of all Americans, which equates to 34 million people, do not have access to what we qualify as broadband. 68% of Americans living in U.S. territories, 98% living in rural areas of the territories, don't have anything that we would consider to be high speed. And that becomes a challenge as we're trying to push greater and greater amounts of data. So we started looking at options for bringing part of what we've built in the cloud down onto the premise. And wanted to look at what were the desired solution criteria to be able to do this. One is clearly survivability and severability. You don't want patient care to stop if the connection goes down. You don't want to be dependent on something that you can't contain within your facility. We wanted a universal code base. We want to be able to run the same application locally and in the cloud. I don't want to have to maintain two separate types of applications depending on where I'm going to execute that application. We want security to be tight, but we want it to be very, very simple. We do not want to have to manage multiple methods of security because that introduces risk of failure, that introduces complexity where we really don't want to see that. Redundancy, of course, is important, scalability, and we wanted a single point of management. We want both our customers and our staff to be able to go in and say, okay, here's the entire system end to end. I want to be able to manage it with the same set of tools. And I'm going to hand this to Colin for a second because we've been on this journey together. I'll let him discuss a little further what we've done with Amazon.
Well, first off, thanks to Philips and to Rich for inviting me out here to talk a little bit about what we've been working on together for the last little while. So I want to start and talk a little bit about, from AWS's perspective, this journey we've been on the last few years. So I have, as far as data management and data transfer goes, so I really have two roles in my job. One is two hats. One is the leader of Amazon Glacier, which for those of you who aren't familiar with it is our large-scale archival service. So the business there is really how do you store data securely for long periods of time for as little money as possible. And the second job that I have is AWS Snowball, which really sort of emerged out of that Glacier role. And the problem that we were facing a couple years back was I'd meet customer after customer where the conversation didn't really center around so much being able to store their data in Glacier and make use of the rest of the AWS platform. It centered really around how the heck do I get the data into the platform to begin with? And it turns out that's actually a really, really complex problem when we're talking about petabytes or tens of petabytes or greater of data. And there's really sort of two solutions people approach that with. They sort of either go for a network-based solution, where they provision as much network as they can, they transfer the data over a number of years. It's quite costly. You have to sort of set that up, then tear that down once you're done that one-time migration. Or they look to physically ship the data around. And when you're doing that, now all of a sudden you sort of have another big set of problems around logistics, security, and just transfer speed in general. And how exactly do you manage that? So our solution to that is a device that we call Amazon Snowball. If we can advance the next slide. I'll just keep talking. Rich, can you try? Okay. So Amazon Snowball is a ruggedized shippable storage device that stores 80 terabytes of data. The approach that we took is to have the storage device itself become its own box and its own label. So this is an example of the next generation hero we can just take a look at while we're trying to get the slides to work. So essentially what you have here is an 80 terabyte storage device that it ships itself. So the idea here is to really bypass the internet, where rather than shipping it over a very small sort of thin pipe from A to B, we can ship you a snowball, have you fill up that snowball at high speed with a 10 gigabit connection, fill it up over the course of a day or so. Once it's actually full, then turn around, ship that snowball back to us where we can then ingest it at our region at high speed. So it's really essentially a means by which you can bypass the internet and physically ship data from A to B. There we go. Can I have that back? Thanks. So we did a number of things there. Like I mentioned, it's a fully ruggedized device, so please don't do this, but you can drop it off a two-story floor onto hard concrete, and it can survive that. It's really meant to sort of survive the rigors of shipping itself. It has that e-ink shipping label, so it actually ships itself in terms of popping up the right address to either get to you and then back to actually the region. And it has very detailed end-to-end encryption, the idea being that while the device is in transit, there's no keys on the device, all of the encryption takes place off of the device, so the bytes themselves are actually unintelligible to any would-be interceptor of that device. We've gotten HIPAA compliance already for the device, and this is really where we started. And this device, if we could advance to the next slide, this is no longer working. Oh, there we go. So this just shows. No, it's back then.
Just nod when you want to click.
Okay. Let's go back. So this just shows the overall workflow. So you would go to our console, you'd create a job, we'd then ship you a Snowball, you'd connect it into your data center, fill it up with data. Once you're done, you unplug it. That e-ink label pops back to be our return address automatically. You ship it back to us, and then we'd ingest it at high speed into either S3 or Glacier. And once we launched this about a year ago, we discovered a number of really interesting things. The first was that we really had a migration mindset when we were thinking about Snowball. So it was really designed around the case of you have 20 petabytes, 30 petabytes, sitting in location A, and you want to be able to get that to the cloud, much, much more quickly than you could over the internet and with far less expense. And what turns out when we got out there, all of a sudden we started hearing from some customers, Philips very much included, where it's like, well, that's interesting. If you could do just these 2 or 3 other things, then we could use these devices in such an interesting context on our site at the edge, in a hospital setting, in a number of other settings around industry. And they didn't really sort of think about that as much of a migration job as it really is sort of a data collection job. So the idea here is that you have some sources of data out there in the world that are generating local data. That data needs to be captured, processed, used in some interesting ways we'll dive into here in a second. And we really sort of rethought the device and came off with, okay, how can we tackle this data collection problem? And it turns out there's quite a few things involved in data collection that we weren't really handling with the original Snowball device. So the first thing that we didn't handle was, the original Snowball was really sort of a data transmission mechanism. You wouldn't want to store data on there and then sort of count on that as the only existent copy in the world while it was in shipment. It could get destroyed, it could get lost, anything could really happen in that sort of transfer process. So the first things that folks needed to do was they needed somewhere where they could durably store the data and rely on it to be kept for them, both securely and then with enough reliability that they could trust that being the sort of single authoritative copy. Next thing that they wanted to do was they wanted to be able to actually access it while it's on site. So we provided an NFS interface and an S3 interface so that either humans or even machine code could go in and make use of the data locally. And then finally, there was also a big ask for folks who wanted to run local compute on the actual Snowball itself so that they could use it to replace a full system or set of hardware. So rather than having to have this sort of small data center in a particular case where, let's say it's a hospital or, this is even really sort of out in places like oil fields and mines and places like that, they could replace some of the key processing and compute elements and run those on the Snowball itself. And so that led us to this device here, which we call the Snowball Edge. So Snowball Edge, much like Snowball, has very deep end-to-end encryption of data while it's actually stored on the Snowball device. It's ruggedized, has 100 terabytes of capacity, and the e-ink shipping label, much like the original Snowball. But it also does 2 interesting things over and above that. One, it has that compute platform where you can use our container service, Lambda, and run the same code that you would run within AWS on the actual Snowball device itself to process data as it's coming in, run longer running processes to provide interfaces to modalities and whatnot. And then it also has clustering. So then rather than being limited to just a single 100 terabyte Snowball to store data on, you can actually add a number of Snowballs together and then write to it as if it's a single cluster. So you could say get 6 or 7 of these and then be able to have 600 terabytes, 700 terabytes of capacity that you could be writing to at a particular location with redundancy across that cluster so that if one of those particular devices was lost or damaged, the durability of the data is maintained. And so this would be just an example workflow of the sorts of things you could do with a Snowball Edge. So in this case, there on the left, you have an IoT device. So this could be some sort of modality in the hospital that's generating a lot of data. Data then is flowing through either an S3 interface or an NFS interface onto the cluster of Snowballs. That cluster is maintaining the security. It's encrypting all of the data for you. It's providing durability across the number of Snowballs that you have in the cluster, again, so you can lose one. You're then able to run Lambda functions against the actual data, either as it's coming in or asynchronously afterwards to process the data as you need. It can be accessed by other services to actually consume the data or by people to consume the data. And then finally, when you're done with it, you can ship some or all of the data back up to the cloud for long-term processing and long-term retention. So, number of use cases that are of interest here. One is obviously this sort of initial data collection, processing, and transfer use case. Another one that's become really interesting for us is the business continuity use case. So there's places, as Rich alluded to, where a loss of connectivity could be catastrophic or just unacceptable, and you need to be able to keep vital services running in the case where you've lost that connectivity. So the Snowball Edge can basically form a means where you can serve, you can be capturing local data, doing local processing, in the case where you do not actually have connectivity to the internet. So, hand it back.
So for us, we looked at some of the initial use cases that we would leverage this. And what we've done is we've taken the Snowball Edge device and integrated that into the larger Health Suite play. And some of those initial tasks that we looked to place on this include secure messaging, such as HL7. It's a perfect environment for doing lightweight processing using a Lambda function. Cloud-based DR, which we've talked about extensively and will always be important to us. And then we looked at one of our specific products, our existing products, the IntelliSpace Console Critical Care, as our proof of concept, as our POC for Snowball Edge and Health Suite. And so for those who aren't familiar, the Console Critical Care is a patient-centered ICU dashboard. It's a Class 2 medical device, and it provides visualization of data. It handles inbound continuous streams of inbound data points from patients, and it provides checklists and smart alerts. So it's very critical to the ongoing operation of the floor. Working with Colin's team up in Seattle, we started a rapid delivery project to try to take our existing solution and see how quickly we could refactor and deploy it. And we achieved that in a very short amount of time. It gives us all of the things that we've talked about before, which is storage and compute on-prem that is still linked back to the Health Suite cloud. It provides us a secure, tamper-proof, and fully encrypted environment, and it provides us the redundancy and resiliency that we need in this critical patient care solution. We're able to run that using Lambda for data transformation. We're able to maintain the real-time data analysis that we've done for years on top of this suite. And we're able to completely function completely without the cloud there during an adverse event. I'm going to just kind of step ahead. What I really want to do now is to open up to Q&A and kind of talk about some of our specific plans for this and how this would fit into your environment, if there's questions.
Did anyone have a question? All right. Well, in that case, I imagine we could take those offline for a couple of minutes if you guys are still around.
Great.
And in that case, I'd like to thank all of you very much for being here. Thanks, guys. We appreciate it. That was great. Oh, I'll see if I get that quirky clicker there. Thanks so much. All right, everybody, and we appreciate all of you being here as well. We invite you now to join the discussion on Twitter, and also come on back at 3 p.m. We've got a great presentation. Jeroen Toss will be back again with Rick Valencia, the president of Qualcomm Life, to talk about open ecosystems and the power of many. If you would like to get a list of all of the topics, we have programs available right over here on the desk, so grab one of those before you go. And we are growing fast and furiously here at Philips, so if you would like to be part of the Philips team and find out more about how that might happen, we invite you to check in with Dominic and Justin, and they'd love to talk to you right over there. So thanks, everybody. Hope to see you back for a great presentation at 3. Thank you.